Types of hydraulic cylinders. Hydraulic cylinders come as either single or double acting. If only one chamber is pressurized by the hydraulic fluid, it is a single acting, otherwise it's double act. 1. Types of cylinders based on principle. 1.1 Single acting hydraulic cylinder. There are single acting and double acting hydraulic cylinders. As it can be deduced from the name, the single acting cylinders only operate to one direction. In a single acting cylinder, there is one chamber that receives pressurized hydraulic fluid. Which side that is will depend on the intended use of the cylinder. If it is meant for a pushing motion, the chamber opposite the cylinder rod will be pressurized. The other chamber is usually spring-loaded to cater for the retraction. If the chamber with the cylinder rod is the one pressurized, it will be a pull motion. The opposite chamber will also be spring-loaded to cater for the protrusion. 1.1. One advantages of single-acting cylinders is simple to design, manufacture, and easy to install. This is low cost of initial purchase. In single-port input and small housing, reduces the costs in valve and piping cost. 1.12. Single-acting disadvantages. The thrust generated by the cylinder is reduced due to the spring that is supplying an opposite force when the spring wears off. The strokes of the cylinder will become inconsistent. 1.2. Double-acting hydraulic cylinder. Double-acting hydraulic cylinders operate to two directions. The cylinder is moved to two directions, with hydraulics as in back and forth or out and in. Piston separates the chamber, and as the oil pressure affects the piston moves the rod E. The oil affects to the piston's front or back when the cylinder rod moves to both directions. Double-acting cylinders are used, for example, in excavators' booms. The excavator's co-op needs to be moved back and forth, and these both movements require a great amount of force. In a double-acting cylinder, both chambers can be pressurized. Of the two chambers, the one that accommodates the cylinder rod will have little surface in contact with the hydraulic fluid, since we cannot take into account the surface area of the piston already occupied by the cylinder rod. This difference in the surface area will need less pressure to retract than the other. 1.2. WSE1 advantages of double-acting cylinders. It has a lot of control over movement, considering pressurized air moves both ways, eat faster, stronger, and use less energy. Insys brands a variety in design options. For stroke and bore sizes, it offers a force in all directions, that is push and pull motions. 1.2. Two double-acting disadvantages. This is costlier than single pneumatic cylinders. They need a bigger housing if used, for example, as a feed cylinder, because of the coupling required. 3. Types based on the three most popular hydraulic piston configurations are ram styles, tie rod, and welded. Tie rod cylinders utilize threaded steel tie rods with great strength, usually on the outside of the cylinder casing, to provide additional stability. Welded cylinders incorporate a heavy-duty welded cylinder housing that has a barrel welded right onto the end caps and thus requires no tie rods. Ram cylinders usually have no piston, but rather use the cylinder rod as the piston. 3.1 Hydraulic ram cylinders. Single-acting hydraulic cylinders that have no pistons, but have large rods are called rams. These rams operate exactly like the conventional single-acting cylinders. However, they use large diameter rods in place of pistons and piston seals, and thus in place of pistons, rams have high-pressure cap-end ports. They also do not have any low-pressure rod-end ports. Rams are generally cheaper than their conventional single-acting cylinders counterparts. Ram types of hydraulic cylinders are typically used to give vertical motion, including lifting loads in a vertical direction. Such a cylinder is also used to provide the motion in a horizontal direction, but needs attention and suitable guides to guide the motion. A good example of a ram cylinder is a telescopic cylinder. 3.2. Two telescopic hydraulic cylinders. Telescopic hydraulic cylinders are also known as the length of a hydraulic cylinder is the total of the stroke, the thickness of the piston, the thickness of bottom and head, and the length of the connections. Often this length does not fit in the machine. In that case, the piston rod is also used as a piston barrel, and a second piston rod is used. These kinds of cylinders are called telescopic cylinders. If we call a normal rod cylinder single stage, telescopic cylinders are multi-stage units of 2, 3, 4, 5, or more stages. In general, telescopic cylinders are much more expensive than normal cylinders. Most telescopic cylinders are single-acting, plus double-acting telescopic cylinders must be specially designed and manufactured. These are a type of linear actuator consisting of a series of tubular rods called sleeves. These sleeves, which are typically 4 or 5, sequentially decrease in diameter. As the hydraulic pressure is introduced to the cylinder, the main or barrel, which is the largest sleeve, is extended first. Once the barrel's gotten to its maximum stroke, the next sleeve then begins to extend. This will continue until the cylinder reaches the last stage. 3.2.3 tie rod type cylinder. This cylinder holds the two caps of the cylinder barrel, ends using threaded steel rods. Tie rods can number all the way up to 20 depending on the bore diameter and operating pressure. One of the big advantages of the tie rod is it is effortlessly stripped and examined for repair. Tie rod cylinders are used in a large majority of industrial manufacturing applications. Smaller bore cylinders typically have few, maybe 4 tie rods, whereas larger bore cylinders can have as many as 20 tie rods in order to weather the forces produced by the cylinder. 3.2 EU4 Welded hydraulic cylinder. In a welded rod hydraulic cylinder, often the barrel gets welded directly to the end caps. The head cap can utilize a variety of retention approaches, such as threading or bolting down. This design is generally accepted for mobile equipment because of the compact construction, inside bearing lengths, and its duty cycle compared to tie rod construction. But this design does make inspection and repairs a lot more difficult in the field due to requiring less common tools and equipment. The welded rod cylinders are welded and also have loftier seal packages. These help to increase the life expectancy of the cylinder and are helpful when the cylinder will be used in locations that include contaminants and weathering. Visual